Welcome back to the GIS Day 2024. Thank you very much for remaining with the program, and we truly believe that this fruitful session has provided you with valuable insights and knowledge. As per the agenda, we will now proceed with the session on applications of LiDAR data. To conduct the session, I respectfully invite Dr. G.S.N. Pereira, Head of the Department of Remote Sensing and GIS, Faculty of Geomatics, Sabragamu University of Sri Lanka. Please give a round of applause to Dr. Sanka Pereira.
Okay, very good morning, I think. Yeah, still good morning. Good morning to everybody. And our keynote speaker, Dr. Basnaika, and the Dean of the Faculty of Geomatics, and the sole sponsor to the World GIS Day, the Managing Director of the Global GIS Private Limited, and all the chair and the secretary of the World GIS Day celebration, Professor Kosathan Pasupusel, and my colleagues and students and ladies and gentlemen. You all are welcome to the session on use of LiDAR data for GIS applications and advantages and emerging trends. Let's explore the fascinating intersections of LiDAR technology and GIS and their impacts of spatial data analysis. I think in the morning we heard a very nice, informative, and technologically rich the keynote speech by the Dr. Basnaika, but I'm not going to deep that much, and assuming this is a general community, I'm just going the general knowledge of this talk. And so that I'm starting with a very simple questions like what is LiDAR, even what is GIS, and though everybody knows this. And then we talk about a little bit about the applications which we could use LiDAR data for GIS, and some advantages and some future trends and as well. Okay, so have you ever wondered how precisely and how accurately 3D models are constructed which characterize the 3D environment around us? This is the place where LiDAR plays the role to GIS. So, what is LiDAR? Actually, and obviously it's an acronym, stands for light detection and ranging, and which everybody knows this, and the system uses the lights primarily in the form of lasers to measure distance. Whenever the laser pulses meet an object, it's bounce off, so then a certain portion will be reflected back towards the sensors. By measuring the time of flights, that is travel time, as Dr. Basnaika mentioned, the system is able to compute the distance to the objects. So this is a little illustration how it works. but I'm not going to talk about these components, subsystems and things. And so then the next question might be what can we get from the LiDAR data? Knowing the position of the place where the pulses emits, and knowing the distance between the sensor and the target, in addition to that, the computing or the measuring some other parameters like inclination angles and things, and the system is capable to compute the positions where the returns come from. If this the system knows the 3D positions of the platform where the pulses emits, definitely the system provides the 3D information of the positions where the returns come from. So that what we ultimately get is the 3D positions of the places where the returns come from. Definitely nowadays there are LiDAR systems which emits the billions of pulses per second, so that similarly the billions of returns will be measured by the system, so that what is ended up is the billions of point clouds. The specialty of the laser is basically it's a monochromatic, coherent, and the collimated beams, so that which enables the lasers to pass through the gaps within the vegetation canopies, so that which enables to see underneath the vegetation. This is the only remotely sensed data acquisition technique that have been used and that have been able to see underneath the canopies. And on the other hand, nowadays most of the LiDAR sensors are capable to measure the several returns for a given one single incident pass, so that the multiple returns are also possible. What else the LiDAR delivers for us? Now we know that we'll obtain the XYZ positions where the returns come from, and most of the systems are capable to measure the strength of the returns, that is the intensity. But comparing to the multispectral sensors, the LiDAR sensors basically rely with one single pulse wavelength, so that the spectral information which we have extracted from the LiDAR sensors are comparatively less comparing to the multispectral sensors. But nowadays there are multispectral LiDAR, so that which enables more spectral signatures, more spectral information can be, which enables us to obtain more spectral signatures, but which is still unable to reach the level which provides the multispectral sensors, or because there are hundreds of bands like the hyperspectral. This is it's still a challenge for the LiDAR manufacturers. So basically, I will get the XYZ points and also the intensities, and having capability to measure the number of returns, so the return number of returns, and in addition to the travel time of flights, that is the GPS time for each return, and also the scan angles and several other informations also measured by the system. But basically, we basically need only the XYZ and as well as some intensities. These are some of the attributes we use. And if you talk about the types of LiDAR systems, and generally as the other categorizations, and the systems can be categorized basically respect to the platform, actually the altitude of the platforms from the above ground. So that there are spaceborne, and there are spaceborne LiDAR missions. For example, NASA GEDI mission, which delivers the point clouds, but which is not in that much of, or the densities is comparatively less. The other types of LiDARs are the airborne laser scanners, and that can be either the manned or the unmanned. So nowadays it's very popular for the unmanned LiDAR, the UAV LiDARs. So The other one is the LiDARs, which are mounted on static positions, that is the terrestrial SS scanners. And the other platform is the mounting the sensors on top of the moving vehicles, that is the mobile SS scanners. Sorry. These are the systems that are being used to capture the LiDAR point cloud in the geospatial industry. So on the other hand, we have the GIS. So I'm sure everybody knows the simple answer for this question, what is GIS, but I would say that it's a computer-aided system which uses to store, manage, and as well as analyze, visualize geospatial data or the information. So what are the components of GIS? So definitely there should be a hardware that can be not only the desktops, and it might be goes with the mobile devices as well as. In addition to that, we have to have the platforms. So these have to have the softwares, and these two are not sufficient. So we also need the data. Without data, we cannot do anything. So even though we have the softwares, hardwares, and the data, we need the personnel to process this data. So this is the end users must be a component, and there should be some rules or the criteria or the methods. So these are the components. So in this talk, we basically talk about the focus, the data, that component. Why is LiDAR make a such game changer for GIS? That's the question. So then the answer is actually the LiDAR delivers the very high density point clouds. The resolution is very remarkable and incredible, and so which enables us to extract very thin or tiny informations as well, which are not able to extract with other systems, which are other remotely sensed data collection systems that we use at the moment. The other one is the inherently LiDAR consists or contains the third dimensional information. The other one is the accuracy. The LiDAR delivers an incredible accuracy at the moment. So these are the main reasons that makes the game changer for the GIS. Okay, so what are the data types which can be used for GIS from the LiDAR? So straight away we could use the raw point clouds. Actually, the raw point clouds are stored in the form of binary files. But to say that is the laser, so that the world standard is to use rename this as the .las. So then we could straight away use the LAS for GIS environments, and in addition to raw data, we could also use with some additional attributes like the classification label, so that we can straight away use the classified point clouds as well. Not like that, and we could also use the surface elevation models or which are derived from the LiDAR point cloud as well. In addition to this data and some of the raster derivatives like the canopy height model, that is this difference the difference between the surface and then the elevation models. Also slope and aspects are some of the raster derivatives which can be used as input for the GIS. Okay, actually the LiDAR, it has its own processing chains, and but when you come to the GIS, and these processing chains can be categorized basically into two steps. There is the two stages, the pre and the post processing. Basically, the pre-processing, what we are doing basically is just to remove the noises, because there are because of the multipath and some other DNS issues and some other system issues, and there are some errors exist in the LiDAR point cloud. So these are the outliers, and so this outlier removal and having the high density point clouds to be able to manageable data sets, that is reducing the densities, that is downsample, can also be done even during the pre-processing stages. And other things are all other things comes under the post processing. So this the classification steps that the point clouds can be classified into different classes like the terrain, building, vegetation, as well as the roads, water features, and several things are coming under the post processing. And also the deliverables like the generation of DSM, DEMS, and also as I said, the canopy models, and all these things everything comes under the post processing. And there are specific software, so the tools being developed by the geospatial community, especially for the LiDAR data processing. For example, LiDAR 360 and the 3D surveys, and also like the TerraSolid products, but the GIS platforms, they are also incorporating several essential tools which could especially use to process the point cloud, so that the ArcGIS Pro, then QGIS, and there are several options and facilities are already inbuilt with their platform. So if I talk about the applications that we could use LiDAR point clouds in GIS, there are several applications. I just focus into the few. And for the urban planning and management, this is one key application where we could use point clouds. Having high density point clouds and having these point clouds, that's point nature, is a very high potential to reconstruct the 3D city models with a very detailed accuracies and with high level of details as well. Actually, by integrating the textures to the polyhedral models and this type of picturesque products, or the reconstructions are nowadays is no longer an issue with the GIS tools and the platforms. And actually, there are several challenges which the users has to face when we are processing with the point clouds. The one is the point densities and the point data gaps and several things. So it's based on the densities and the level of details that can be reached that's rely. And these are two examples where we can go with the high level of details and the low level of details with different densities. Another area where we can address, so we could use the point cloud, is the disaster management. And I would give you a very good example. Actually, the Holland was the first country that has the nationwide LiDAR coverage of the entire country. So, because as you guys know, as you know, the northern territory of the Holland, which is it's below the sea level. So the Netherlands people wants always to monitor their land area. So they have to build kind of barriers or the walls just to stop the seawater coming into the land area. So they were the first people that they generate the high accuracy elevation models from the LiDAR point clouds. Actually, that happens nearly 3 decades back. So that at that time, the point density was the 1 points per square meter. But nowadays, with the airborne analysis scanners, that goes beyond the hundreds, so nearly 100. So we can get high detail point clouds as well as high detail elevation models as well. And another aspect is the hydrology. And so basically, for the floodplain and flood simulation modeling, the LiDAR plays a key role, and this is one key application where we could use LiDAR within the GIS environment. Actually, a couple of nearly 2015 or somewhere, and one of the project also used, and there is in Sri Lanka there is a certain coverage of LiDAR that also used for this type of floodplain mapping, and this was done by irrigation. And these are some examples where the influence or the inundation area mapping with the rising of the river water. The another application is the environmental studies and having series of multi-temporal LiDAR data sets along the coastal belts, and then it's easy to compute the erosion volumes. Then that's play another role, and another key area where we could use LiDAR point clouds in GIS environment, and the other one is the mining industry. And in the mining industry, the volume computation is the most important factor. So with the high accuracy provided by the LiDAR point clouds, I mean the elevation accuracy, basically most of the mining industry, the mining firms are looking for the LiDAR surveys for their computations. This is another example that we could use the test laser scanners for the mining industry, and because of the undulation of the mine surface, so the one scanner is not able to cover the entire the mining site. So this is the the co-registered in order to get the seamless one data set. So the co-registration is necessary. So prior and after the mining or the excavation, so having these type of two data sets and the computations, the volumetric computations, precise volumetric computation is no longer barrier in the GIS environment nowadays. This is some of the places where the mining has been done, and it's the only example. Another the remarkable area where we could use the LiDAR point cloud is the forestry and agriculture. With having the digital surface model and also the elevation models, the difference is the canopy height model, especially in the vegetated areas. So having the canopy height models, so the biomass computation, precise biomass computations can be done with the LiDAR point clouds, and which is able to do with the GIS platforms nowadays. And having high point densities, the individual tree isolation can also be done, and the automated algorithms are there and just develop, and these are already there also in the GIS platforms and also some of the professional tools, so that the individual biomass estimation for in each individual trees also are no longer issue in the GIS environments nowadays. So another application area is the archaeology. This is just only example. So that any damages or something, and then we can be nicely recognized with having this type of nice detail archaeological monuments, and just enforcing the symmetricities and other constraints, and we are able to fill what is missing or something, also possible even in the GIS platforms. And the other area is the infrastructure management. Having classified point clouds and the reconstruction of the 3D landscape, like the reconstruction of this type of the power lines, is a no longer issue in the GIS platforms and as well as the professional platforms, and the so that some of the studies like the estimation of the safety nets in the settlement areas, and any kind of decision making can be done by the electricity board peoples when it's necessary. Having classified each and every components of the towers and the reconstruction of these towers, 3D reconstruction, 3D towers is no longer an issue, and these things can be easily implemented even in the GIS as well as other professional platforms, and also even the open source tool as well. This is an example data set for the mobile laser scanner point cloud. So the classification of points into the road surface, and the vegetation and other types is also possible. Then, as I said, that the intensity is another additional parameter having this intensity, and these the what you call the painted the center lines, and everything can be extracted. And so, at the end of the day, this type of 3D urban reconstruction also possible even in GIS environments. Another application is having the detailed 3D landscape over the urban areas, and the utility net layout designing and something like studies are feasible. The another application is the building information modeling, having the different sensors with indoor data model data collections, and the having the indoor models, indoor builder models, and going for the building information modeling. It can be achieved easily in GGS environment. So, and the other example that can be given is for the tunneling industry. The maintaining the flatness and also the similar uniform tunnel profiles is a key requirement for them, and so these type of requirements can be done even in the GIS environment if we have the detailed point clouds. Okay, so if I say what are the advantages of LiDAR in GIS, basically, obviously the high density or the high spatial resolution or the high density is one aspect, and the other one is its high accuracy. And comparing to the other systems, and the LiDAR is one of the fastest remotely sensed data collections method at the moment nowadays. So this is one another aspect. So the other the advantage is the LiDAR data point clouds can be applied for multi-purpose applications. This is another application. And having the point clouds comparing to the 2D raster data, actually the point cloud has high automation power. So this is another advantage. If I say what are the challenges when we are using LiDAR in GIS, actually the LiDAR sensors are still very expensive, so it is unable to afford for many of the surveying firms. So this is one issue, and also having high density point clouds. So then another issue is the hardware issues generally comes another primary factor. So then the significant storage and the high computation power machines are necessary, and the other one is the complexity of the data. Unlike the raster data, these are regularly spaced the cells. The point clouds are irregularly distributed data. So even in the terrestrial laser scanners or the mobile laser or the airborne laser scanners, the densities are not uniform. It's different from place to place. So which is another issue that most of the LiDAR processing experts or GIS experts are facing. And the other one is when we are handling the LiDAR data, I just need a little bit on kind of an extended experience, so that the training is or another additional factor. Okay, if I say the future of the LiDAR in GIS, so because the sensor, the expensive, unable to affordable, is a one factor. So then the manufacturers are always looking for affordable products. So their concept is to miniaturation. So that nowadays the manufacturers are always looking to develop mini and micro drones, and as well as mini and micro LiDAR sensors. So that is another one type of future, and the other one is now we are moving towards the automated concept. So then the AI, Internet of Things, and the cloud computing can be integrated with the LiDAR data and as well as GIS. Then only we will be able to do and real-time analysis of things. And the other one is since we are moving towards the automation and also the robotic concepts, the real-time data capturing, as well as real-time data processing, and also the real-time data decision making is essential. So that then we can move. So then the good example is the self-driving cars, and by achieving this real-time the processing and the acquisition and the concepts and the self-driving or the automated or the going towards the smart cities is no longer a challenge anymore. These are some of the insights that I would like to share with you, and I'm happy to answer any questions that you have.
Sanka, thank you very much for your nice presentation. So, what I'm thinking about, what are the limitations of this LiDAR? So, we can't use LiDAR actually.
Actually, the one is the measuring range. When it comes to the terrestrial laser scanners, the measuring range is limited to the nearly less than 300 meters, and if you go for the drone-based systems, and nearly the altitude that we can reach is it depend on the capability of the system sensors, and is also limited. And the one limitation in that sense is the data coverage. That is one, and the other limitation, the one most predominant limitation is the data gaps, and occlusion makes gaps, and then that data is lost already. So then we don't have the data. So, for example, if we can reconstruct the building models or any models either by the two ways, and there's one is the model based, and the other one is the data driven. So then if we are going with the data driven methods, then the data gaps is a challenge. So we are lost the data, and so maybe then we can predict something, or we are having a product with some gaps.
If I'm talking with the people, I would know that the water and the muddy sediments.
Yeah, of course, yes. Yeah, and
What's their future versions? We can get something penetrating.
yeah, actually I didn't talk that time actually, and there are the bathymetric lidars, and that can penetrate so that is the green laser basically penetrate through the water. Integrating the topographic, the red laser and the green lasers, we are able to capture the terrain topographic data as well as the bathymetric data. But there are some limitations of the purity of the water and some things, and there is limits the penetration depths as well. Actually, there are several factors which influence the point densities. One is the pulse repetitive frequency. There is a number of pulses which emits per 1 second, and the other one is the speed of the aircraft and the scanning rates. And these are some factors are there. So if our objective is to increase the point density, which basically then we can go for at least some sparse points underneath the canopies. So having the high density, I mean the high number of emissions is a requirement. So there's one requirement. That the other one might be then we can go if we are able to um, embeds the multi-frequency, or I mean the multi-wave lens, that is multispectral LiDAR. That might also be an assistant. Just okay. Shall we wind up the session there? Okay, thank you very much. Yeah. So yes, yeah, there are issues. The multipath issue is there. So the multipath issue definitely, we get the point cloud that the multipath makes errors. That is the outliers or in some outliers. So then we have to recognize these. For example, when the LiDAR sensor scans the terrain, for example, let's say, we'll see some kind of some isolated or cluster of points below the surface. These are outliers, so it might be a reason for the multipath. So we have to recognize these things, and otherwise we can write some kind of an automated processing routines or algorithms just to recognize these outliers and then just remove these prior to taking the data for the applications. Yeah.
So how can you find out the accuracy of that particular word? According to the accuracy, or whatever the data we are detecting, how do we get that accuracy?
The accuracy is, there's two things, and the one is the sensor, some of the sensors, for example, different products, different manufacturers develop different sensor systems, and the accuracies, that the point cloud accuracies are different. That is one thing, and the other thing is the accuracy of the product. So for example, if we reconstruct a 3D building, for example, if two people reconstruct with the same data, can be reconstructed two different models, and their geometric accuracy is different because it's irregular distributed point clouds. So the recognizing the exact edges of the buildings is an issue, and so it's depend on the algorithms or the techniques that we use in the reconstruction. That is another aspect, and there's two things, and to check the accuracies, definitely we have to have the reference data. Then only this is the only way which we could. Okay. Yeah, thank you very much.
A heartfelt thank you to Dr. GSN Pereira for your insightful and informative session on the applications of LiDAR data. And sir, we truly appreciate the time and effort you have taken to share your knowledge with us today. As per the proceedings, we will now move on to the session on open source GIS applications. To enrich our gathering with his valuable expertise, I cordially invite Professor Saman Koswata, Professor in GIS of the Department of Remote Sensing and GIS of the Faculty of Geomatics, to conduct the session.
Thank you very much, Susan. Hi, I would commonly say you as GIS lovers, so I would not insult you. And this is going to be the first time we are organizing this organizing this event to celebrate the World GIS Day. And in future, we plan to make this event even improved one, right? So I may be the happiest person here because this idea was in my mind since long ago. So only this year I could make this a reality with the support of our industry, or the sponsors, and also with your help. I'm really happy to see you all gathered here. So I like if we can make a discussion, and we are from the industry, most of you, and also we have students here. So the final, the mostly benefited people will be our students. If you can discuss with them, if you can point out what are the issues what we have in the industry, and they can help with their research, maybe how to solve these problems what you have. In most of the developed countries, we see this strong connection in between the industry and the maybe higher education industries or the researching organizations. This collaboration is very beneficial, right? Unfortunately, we don't have such a culture here. Our attempt is to make this happening, right, in Sri Lanka. So in future, we can have a good relationship. So this forum will be a good starting point, I believe so, right? Today, my presentation will be on these modern World GIS applications. Initially, I was thinking about discussing something about open source GIS applications. There is only one side of this GIS, so I slightly changed this thing to talk about this, the modern World GIS applications. When it comes to this GIS applications, again, it got two folds, right? What we do, the theory, we apply the theory into practice. That is one side of applications, and the other side is the apps what we are developing. So there is another angle of this same thing. When we talk about applications, we have to think that thing in our mind. So it will not limited to the application, not only the apps what we develop, and also it will not limited to the applications, that is applying all these GIS theories in the real world as applications. All right, I decided to start with the technology revolution we are experiencing today, because without the technological support, there is no point of discussing about GIS. GIS, the foundation is technology. The technology we can see, it is keep changing, keep improving. With these improvements, we have to integrate. So definitely GIS is built on top of this, all the technologies what we experience in these days. So in future, we have to see where the technology is moving on. So with that thing, we have to decide how we are going to change our applications. Without that vision, in some stage, we will fail our attempt. So definitely we should have some idea about how this technology is changing, what happened in the history and what will happen in the future. So this, the industrial revolution. So in the beginning, it was the people attempted to include machines, so hand over all the tasks what we are doing to the machines, right? Machines taken over all the very heavy work we do, or the complex jobs we did at that stage. Then in the next stage, the mass level of production, these machines, the simple, the working on, the people tried to make it in large forms, right? That was also successful. In the next level, what happened was the computers introduced into this, the industry. So most of the time, it was used computers. What we are experiencing now is in the middle of the industrial revolution 4.0, right? So that is the integration of AI technologies. Artificial intelligence is connected with these machines. So we can see a lot of improvements are there. So some knowledge level working is going on, right? When something is done with the humans, there can be a lot of errors. So we can minimize these errors, and the efficiency we can improve with this, the inclusion of the AI related tools and technologies. And we have to remember that we should not slaves of these artificial intelligence and all these tools what we have today. It is doing a very bad damage for the students. What I see is that. So it is stopping their thinking patterns, and they getting addicted to these, all the AI related tools, which is a very bad thing in certain stages, like our keynote speaker mentioned. When we are depending on certain things, if they are suddenly stops, all of our work will be stopped, which is a very challenging thing. So we have to keep the balance in between these whatever emerging tools and our own, the basic level work what we are doing. So we can see a lot of industrial related IoT type things are coming up. We are experiencing these things, and a lot of sensors we have in our life. We are using these things, but remember that when you are using particular sensors, there is certain challenge. Somebody will be monitoring you. Be careful, don't again be slaves of these things, right? Keep the balance again. And we have a lot of monitoring tools and automations are going on in this industrial revolution number 4. People are talking about safety. They're trying to establish the safety in their work and the quality standards getting improved. We can see a lot of apps are coming up, and we have the networks as the base. With these networks, everything is became possible there. And we look at what will happen in the next, right? So in the beginning, what happened was human work taken over by machines, right? And keep on going. Now in the next level, what people are trying to do is, again, bring the people or the human intervention back into this cycle, right? In industry 5.0, people are trying to build the collaboration in between, already develop these AI type models, IoT type things, and make sure the quality is there and the failures are in a very minimum level. So that will be the working model in next level. Right, next I want to highlight the modern world challenges. The nature always challenging us because of we are always trying to challenge the nature. So we can't defeat nature, we have to accept that reality. In one point, nature will win the battle, right? So with that thing, always we have to appreciate what nature does. It is always trying to keep the balance in between human work and the its own characteristics. So I like to start with that point because when there are problems, so the real problem comes to us only, we are interested about that. Otherwise, if it is somebody else thing, we don't care it. But in certain stages, we will be victims of these things, like or not, right? I have mentioned here some of the modern world challenges we experience. Recently, we are experiencing a lot of food shortages type things, especially in Sri Lanka, but in common, everywhere economic crises are going on, food shortages, like I mentioned, and natural disasters keep on coming in different frequencies and different levels, right? Then fuel crisis, health issues, we experience a lot of things there with the COVID and national security and many more. So these things keep coming, right? So the important thing is we have to be prepared. So GIS is a very good opportunity. Unfortunately, in Sri Lanka, it is not practiced into that level, right? It is underutilized thing. So our attempt here is to make it useful and people aware about this thing. So our responsibility as well as your responsibility as GIS professionals to make people aware about this thing, right? We have to do something there. We have to put our effort to make this thing used, right? Otherwise, even we, how much we are knowledgeable about these things, no use, right? Ultimately, we have to make these things real. Otherwise, we are not responsible for our country. That is something bad. And next, I want to highlight the opportunities what we have. So the AI is already with us. So that was not the reality maybe some time ago, but now the AI technology is already in the ground level, right? We can see human-like robots are there. This is an example of Sophia. I think that is the most successful, the first successful case to act as a human. It can think, it can speak, and also she can draw. If you ask something to draw in that level of skills, all these are very high-level human skills, right? The AI or the robots are ready to perform these acts, right? But I don't think the robots can replace humans, There is something for us to do even. That's why the industrial revolution, people are thinking about integrating people back into the system, right? So we don't need to worry too much about this area. So we are still, we have some part, they are still left, right? Then the communication technology. Now we are experiencing the 5G technology. We have it with us, right? And in future also people try to increase the bandwidth. So the idea is delivering more and more data in between, but technically the range will become reduced, but in some point we have good bandwidth. We can share the data. In GIS, data also very important part. If you have very efficient way to share this data, which is very advantageous. And the positioning technology, we discussed that thing. Many people highlighted the improvements of these positioning technologies. And with the W3, that is semantic web, we also already have it with these AI type integrations. With knowledge, these things, they can work itself. Very useful technologies. And the natural and augmented and mixed realities. In the initial stages, we were discussing about artificial intelligence, but now these technologies have gone very into top levels. We can simulate the things like we are working with the real environments, so which is very advantageous. Because when it comes to the GIS data, we can't expect all the data what we see on the top level. Something can be underground. So if we can integrate these systems, we can see, we can develop some outputs, right? Some applications like augmented realities or mixed reality type applications, like we are living in that level. We can see the underground type things, and without digging the floor, we can really see where they are located, and which is very advantageous. So this type of technology is already there. And when it comes to the presentations, now we have 3D printers. In earlier days, when we want to present something, right? Physically we can't show that, but with these 3D type printing type technologies, we can create a real type model. So that is much easy to understand. So in that way, technology is moving forward, and we can include lot of features and facilities in our GIS applications. And like Dr. Sankar mentioned, there are a lot of LiDAR type sensors are there. Interestingly, these are becoming very small in size. I would say miniaturized sensors, right? In previously, LiDAR means a big sensor, but now we can have it with our smartphones. With the iPhone 13 Pro, some similar model, they introduced first these LiDAR sensors. They are maybe very preliminary sort of things, but they are getting improved. So we can use LiDAR very easily, which was maybe a dream in certain time. Okay, I'm not going to talk about much of these things, but the sensors are becoming smaller and becoming very useful. That's what I want to highlight. And when it comes to data, in a certain stage, we were lacking of data. But now what has happened? With these, the social media type applications, now what has happened is data is flooding. We have too much of data, right? Now the problem is how to deal with this data. We can see a lot of applications are coming up, how to deal with this data. We might identify these things as big data because of their massiveness, and certain drawbacks are there. They are not ready to use in real life applications. There are some certain threats. Even we have data, they are not ready to use. We have to make them ready. So some work is there. So we can see the volume is high, the velocity is high, they are coming quickly, and variety, they are representing various things. The veracity also high, and there is a big value there. But we need to do something to for making them valuable, right? Without that part, we can't use them. So people identify this thing as volunteered geographic information, which are coming from the social media or this type of different platforms, and some people identify this thing as crowdsourced data. But remember, we can't use them as it is. That is the case there. And information models, we already know what are BIMs, building information models. Another technology improved very fast, right? Now people use these building information models within GIS, right? So when we can include all the things, certain things inside BIM type models, they are very useful. We don't need to worry about the amount of data. Say maybe measurements or maybe planning work, we can very easily do with these building information models. And maybe city information models, as we have a lot of data, as we have the technology to integrate these things, we don't need to worry too much about the information. And when it comes to planning, we can directly use these things for our own purposes. And especially another area now developing is digital twins, like building information models. This is also kind of models which are having real type information, right? We can make a twin of anything. Digital twin means similar to the original object. So the use cases are very, very wide, right? It goes to the medical field, it goes to the engineering field, it goes everywhere. So the advantage is if we have digitally a model of the real object, we can play with it, we can do the experiments. So if you are talking about medical cases, these doctors, they don't need to deal with the real body. Before doing the same thing with the real body, they can practice what are the implications, what will happen if something goes wrong. So they can be well prepared with these things, right? And we can see a lot of the remote medical operations are going on. So they can do this thing with these digital twins before attempting with the real body. So we can minimize the risk there. A lot of advantages are there. So when we are talking about GIS and these digital twins, digital earth, right, type models, they are similar to these, the twins what we are talking here, right? But practically it will be sometimes very difficult work with the level of information. We have massive amount of data to make it realistic like the real world. But one day, as the technology is moving very fast, we can see these products like the real objects. And the GeoAI, geospatial artificial intelligence. So we can see a lot of applications are coming up, real type applications are there. This, the GeoAI, we can break into 3 levels, maybe artificial intelligence, and inside that we can see a lot of machine learning type applications are there, and also deep learning type applications. So why we need this artificial intelligence in GIS? So there are a lot of complex situations we can't model with in our own. This the artificial intelligence can do a lot of things there when the work is very complex, and also if it is time consuming work, we can let these artificial intelligence models to do the work. That is the advantage there. We can see a lot of things there. I'm not going to talk much about these things, but I want to highlight these things because we have to use the technology. So that is where the world is going on. We have to be with that technology. Otherwise, there will be a certain gap. And in agriculture, we can see a lot of smart applications are there. In countries like ours, we are wasting so many things. Maybe fertilizers, and also we will not get the expected the harvest at the end. We have a lot of diseases there, right? If we use the technology in this, the agriculture field, so we can get a lot of benefits there. In developed countries, I have seen people are developing a lot of algorithms to improve their products, maybe monitor their crops, and to calculate the pesticides or whatever things they are going to use in these fields. and they are trying to improve the efficiency. Unfortunately, in countries like ours, we are not utilizing these available technologies. That is the bad point. We have the technology, but normally what we are trying to do is we are using these things in the unwanted areas, but the real thing is missing. We have the capacity, we have the knowledge, but in practice we are not doing this thing, which is a very unfortunate situation. So what I want to highlight is these opportunities are there. If you are in similar fields, please think about these things. We are here to help you. If you want any help, maybe with the knowledge, maybe with the technology, we can help you with that. And what I wanted to do is develop the connection or the collaboration with industry plus the academia. And we can see in fields like disaster management, the crowd-generated contents, what I mentioned before, like VGI or crowdsourced data, we can use these data. So, like I mentioned, they are massive, so we don't need to worry about the data. What we have to worry is how we can use this data back in applications. So the opportunities are there, but we need certain improvements before directly apply these things back in the real life applications. And we can see now it is not matter of dealing with the outdoor data. Normally when we are talking about GIS, we are thinking about the environment. But the technology has improved. Now they can deal with the indoor features, right? Like the models like BIM. So we can include all these information in type of models, and we can use GIS to further make use of these things. We have a lot of tools there, similar things, but with different contexts. That is the advantage there. And also with the security. So in military type applications are there, but with the information we have to be very careful. If the information is very sensitive, we have to think twice whether we are going to include these things in certain platforms like maybe web mapping, right? There are solutions for these things, but in certain cases we have seen people are using very sensitive data without thinking it's the importance. But solutions are there. I can see a lot of applications emerging in the field of security, military type applications, like Dr. Chaminda mentioned, the GNSS technology and other technologies they are using. But the certain issues also there. I encourage you to think if you have some sensitive information, when you are going to publish these things, think twice. So without thinking, if you are using these things in web type platforms, unknowingly this might go to the hands of unexpected people. So there is a threat, but solutions are there. And smart cities. Right? We have a lot of conjunctions in our cities. Roads are very congested, but people are using to solve these problems with the help of GIS and also with the location-based services. We can include, we can think about applications or GIS, how we are going to put into this type of areas. In other countries, they are utilizing these things in practical. Sometimes I notice some people are trying to bring certain applications, but the sustainability is the problem. Enough backing is not given to them, maybe with the industry or maybe with the governments. I don't know where the problem is, but opportunities are there for us to use our GIS skills back in these areas. And interestingly, now we can see this GIS is not only limited to the earth, right? Not our own geography, but we can see now people are trying to use the same theories, maybe with certain modifications in other planets as well. So GIS is not global, it is now universal. A lot of applications are there. A lot of interesting, interesting things are there, but there are certain limitations, like we can't use the same coordinate systems what we are using for our own GIS purposes. We have to think about celestial type coordinate systems, but not impossible. We can see practically people are using these technologies. And with this, I'm ending my presentation. I think you notice certain important areas. Maybe you are already aware about these things, but a certain point to think. I like if you can ask questions. Yes, thank you, Sanchita, for pointing out that thing. That is the most hardest part in our country, the sharing, right? So when it comes to digital twins, we have to include all this data what we have. Unfortunately, the organizations or we have a lot of restrictions there. They are not ready to open their data for others, right? When we are doing research, we have a big problem finding data. We know in certain organizations they have the data, but when we are trying to get the data, they are very pricey. That is going to be a very big burden for us as academics. We are ready to do the research, but we don't have data. So if you are going to create this data ourselves, it will take a long time and it will take a lot of our resources. So if we can come up with the digital twins like models, we have the data already there, but we have to be open. We have to change our attitude. So thinking patterns, if you are ready as the members of the industry, you are representing different organizations, this thing we have to discuss somewhere and come to certain agreements. If we can do that, we can see a lot of improvements there. We have dedicated people to work on these areas, problems what we have. We see a lot of natural type disasters are coming up. We are not ready. A lot of damages are there, but we see we can save these may be lives, maybe resources, if we can be prepared. So we are ready here, but the discussion should go on, right? We have to make some policies. If you have some certain restrictions with the policies, right? If we can create a platform for the discussion, that is the important thing I believe at this stage, right? It is not an impossible thing, but we need all your support. Anyway, thank you for pointing out that thing. That is a very burning issue. And also, as you all are here now, if we can maybe come up with certain MOUs. So because these things are beneficial back to you, because you might have your own problems in your institutions. We can help to solve these things. That is the thing happening in other countries. They have good relationship between the industry and the academia, right? The industry itself doing the funding, but they get the benefit, right? So anyhow, we have to develop this, we have to do this change in our country. Any more questions or suggestions? So this is a very good platform for open discussion, right? So in your side, you will have certain problems, certain limitations, but if you can make a discussion, there can be solutions. Right? If policy level, we can deal with the relevant organizations, we can do the change. Yes.
With the existing platform, so how we can develop the platforms to be suited with the 4D GIS. So
Yes, fourth dimension, you mean the time.
yeah.
Right.
With the
So now GIS tools, lot of GIS tools, we can deal with the time. We can go to the history, right, with the technologies like Google Earth Engine. So a lot of data already there. We need to worry about finding data. What is left to do is develop certain algorithms what we need. Certain small scripts might do a very sophisticated modeling with the time. From the certain satellites start to collecting data, we can go to up to that level, right? With very limited time, we can see how the changes happen over the time. So 4D is not a big issue with these technologies anymore. And with the AI, we can do a lot of things. So if it is a human, it will take a lot of time to see these patterns sometimes, but with the help of AI, we can make it more quick.
Professor, actually, I would like to know about what are the limitations in the agriculture sector applications of the modern application of GIS, especially as I have represented one of the project, especially in the climate resilience building. So we know we already plan to address the climate resilience in the Sri Lanka. So we know what are the limitations and the especially technical gaps in the agriculture sector.
Yes, although we point out the best side, the good side, there are certain issues actually in the when you are going to put this into practice, right? One is the technological gap, right? Our farmers sometimes they are not very knowledgeable with the technologies what we are talking here, but we can solve it. We can educate them how to use these things. And the next thing is the sensors. They are very costly, right? Sometimes we have to use very sophisticated sensors, maybe collecting information with maybe with some diseases, maybe, right? Close range instruments which can detect these, the real things. I think that is the most impacting issues there. Maybe technology is very costly, and certain the technologies sometimes with the limited size of these fields what we have in our country. Certain technologies, maybe satellite technologies, when we are going to apply these things, the areas will be a matter. But we can deal with drones, maybe close range remote sensing technologies are there. Solutions are there. Small issues like what I mentioned still there. But don't worry, the solutions itself are there in the field or the world what we are talking about here. So if any of you have already have with some experience, I like to know these things. So you are in the people who are dealing with these things. Sometimes we only know the theory, we have not field experience, but you might have good experience where actually the problem is. So what we see the problem with our the theoretical knowledge, not the practical knowledge. There will be a certain gap between the theoretical knowledge and the practical knowledge. Yes. Unfortunately not. So a good policy came up maybe several years ago, but it is not practicing to make a solution for this, the data sharing, right? But they are still in policy level, not in practice. That is the situation. Yes. So if අනිවාර්යෙන් සුරංග කියන්නේ අනිවාර්යෙන්. ඇත්තට මේක තමයි වෙන්න ඕනේ. දැන් සුරංගට එක්ස්පීරියන්ස් එක තියෙනවා මැෂින් එහෙම නැත්නම් ඉන්ඩස්ට්‍රි එකේ එක පාර්ට් එකක් ගැන. දැන් ওই විදිහට এডুকেෂන් සයිඩ් එකත් සුරංගගේ එක්ස්පෝෂර් එක තියෙනවා. හැබැයි මිසින් පාර්ට් එක ඇත්තටම maybe අනිත් ඒරියා එක නේද අපේ ඇග්‍රිකල්චර් ෆීල්ඩ් එක වෙන්න පුළුවන්. ඒ ඇක්චුවල් ෆීල්ඩ් එක ඔය තුන අපිට එක් කරගන්න පුළුවන් නම් හැබැයි මේක නෙට්වර්ක් එක වෙන්න ඕනේ ගවර්න්මන්ට් එක. ඒ ගවර්න්මන්ට් එකේ සපෝට් එක ආවනම් අපිට ওই තුන එකතු කරන්න එච්චර අමාරු වෙන්නේ නැහැ කියලා තමයි මගේ විශ්වාසය න ะ. අපි බලමු ඊළඟ ලෙවල් එකේදී ගවර්න්මන්ට් මෙම්බර්ස්ලාත් මේකට ගෙන්න ගන්න. ඒගොල්ලෝ හරහා තමයි මේක වැඩේ වෙන්න ඕනේ. අත්‍තරම් ප්‍රැක්ටිකලි ගොඩක් වෙලාවට අර වගේ මම කතා කරා වගේ ලීගල් ප්‍රොබ්ලම්ස් තියෙන්න පුළුවන්, පොලිසි ලෙවල් ප්‍රොබ්ලම් තියෙන්න පුළුවන්. ඒගොල්ලෝ රෙඩි නම් මේවා චේන්ජ් කරන්න මේක බැරි දෙයක් නෙමෙයි අත්‍තරම්. වෙන්න ඕනේ දෙයක්. ඔව්. Yes, yes. Yes, we see a lot of positive changes they are planning. If they are going on, certain solutions will be there. Anyway, we will start talking with these respective people, and definitely we need your support. So you know the GIS, you know the advantage of GIS, you know how to use it. If you support us, we can do this thing. We'll try to bridge all these things together. Sir. Exactly. These three pillars, if you can combine, definitely there will be very good outcome at the end. Yes, madam. Okay, good. Yes, there is. අන්නේ මයින්ඩ්සෙට් එක තමයි අපිට වෙනස් කරගන්න ඕනේ. ඒකයි ප්‍රශ්නේ තියෙන්නේ. සොලියුෂන් සමහරලාවට එනවා. ඒවා සස්ටේන් වෙන්නේ නැහැ. අන්න එතනයි තියෙන්නේ. ඒ කියන්නේ මිනිස්සුන්ගේ අර තියෙන මතය වෙනස් කරන්න කැමති නැහැ. කොහෙන් හරි අන්තිමට ගැලවිලා වැටෙන්නේ අතෙන්නම තමයි. කොච්චර උස්සලා තිබ්බත් වැඩක් නැහැ. හැබැයි යං ක්‍රවුඩ් එකට මං හිතන්නේ ඇච්චර ලොකු මේ රිජිඩ් මයින්ඩ්ස් තියෙනවා කියලා. මං හිතන්නේ මේ පිරිස එකතු වුණොත් ලොකු වෙනසක් කරන්න පුළුවන් ලංකාවේ GIS යූස් එක පැත්තෙන්. නේද? ඔයගොල්ලෝ මේකේ Oh. I know. පර්පස් එක වෙනවා. අනිවාර්යෙන්. මේක අපේ පළවෙනි attempt එක right start එක මේ තරමින් ඕගොල්ලන්ගේ response එකක් ආවා කියන්නේ අපි ඇත්තටම සතුටු වෙනවා. අපි ගොඩක් motivate වුණා මේ වැඩෙත් එක්ක. ඒකින්ද අපි නවත්තන්නේ නැහැ මේ වැඩේ. මේ discussion එක අපි තව පුළුවන් තරම් කට්ටියව එකතු කරගෙන තව ඊළඟ level එකට අපි පුළුවන් ඉක්මනට යමු කියන එක තමයි මගේ යෝජනාව තියෙන්නේ. අපි පොඩි group එකක් හදාගමු. ඒකෙදි පුළුවන් තරම් ඕගොල්ලන්ගේ තියෙන real situation එක වෙන්න පුළුවන්. ඕගොල්ලන්ගේ suggestion වෙන්න පුළුවන්. අපිට දෙන්න අපි යුනිවර්සිටි එක විදියට රෙඩි මේවට අපිට පුළුවන් ලෙවල් එකේ මේකට ඉන්වෝල්ව් වෙන්න. ඒකින්ද ඕගොල්ලන්ගේ පාර්ට් එක අපිට කරලා දෙනවා නම් අපි ඊළඟට ගවර්න්මන්ට් එක පැත්තට හැරෙමු. මේ වගේ අවශ්‍යතාවය තියෙනවා. මෙන්න ඒකට එක්සැම්පල්ස්, මෙන්න රියල් ෆීල්ඩ් එකේ තියෙන ප්‍රොබ්ලම්ස්, මේක යන්න ඕනේ පැත්ත මෙතනයි කියලා අපිට ගවර්න්මන්ට් එකට පෙන්වන්න පුළුවන්. ඒ ඩිරෙක්ෂන් එක දෙන්න පුළුවන්. ඒගොල්ලෝ චේන්ජ් වෙන්න කැමති නම් අපි බලමු. හැබැයි එහෙම බෑ කියලා හිතාගෙන අපි මේක අතෑරියොත් කවදාවත් වෙන්නේ නැහනේ. ඒකින්ද අපි ෆස්ට් ස්ටෙප් එක විදියට මේක මෙහෙම පටන් ගමු. ඒ චේන්ජ් එක කරන්න අපි try එකක් දීලා බලමු. thank you very much ඕගොල්ලන්ගේ මේම මම දන්නවා ගොඩක් මහන්සියලා වෙන්න නැති යන්නේ වෙන වැඩ අනිවාර්යෙන් ඕන තරම් ඇති. මේ විදියට මේකට කැප වුණා කියන්නේ ඕගොල්ලන්ගේ මේ සයිඩ් එකට GIS කියන සයිඩ් එකට මොනවා හරි ආශාවක් ඇති, මොනවා හරි කැමැත්තක් ඇති, මේක දියුණු වෙනවා බලන්න කැමති ඇති. ඒකින්ද අපි ඉස්සරහට යන් කියන එක තමයි මගේ යෝජනාව. බොහොම ස්තුතියි. තව සජෙෂන්ස් හරි මොනවා හරි තියෙනවද? right thank you very much.
Thank you very much, Professor Koswat, for your enlightening and thought-provoking session. So through this session, as a group of GIS enthusiasts, we were able to point out this today World GIS Day, today's workshop's take-home message as the first brickstone of the bridge that combines the academic field together with the industrial field. So your extensive knowledge and expertise have truly enriched our gathering today. We are truly grateful for your valuable time and knowledge, sir. We will now move on to the next event on industry awareness, and we cordially invite Ms. Nishamani Tharunika, surveyor at Global GIS Private Limited, to conduct the session and enlighten our gathering.
Good afternoon, everyone. I am Tarunika from Global GIS Private Limited. I am here to discuss the integration of GIS with GNSS in the context of revolutionizing industry practices in Sri Lanka. We all know the combination of GIS and GNSS is not a new concept, but the rapid technological advancement and the evolving demand in the geospatial industry make it crucial to revisit and explore this integration with a new perspective. Therefore, the purpose of this presentation is to highlight the latest trends, techniques, and real-world applications where GNSS and GIS are driving innovation and enhancing accuracy and improving efficiency. My aim is to provide insight into how we can effectively leverage these advancement into our workflows. I'm not going to take much time since we are running out of time. I will start by explaining why integration of GNSS and GIS. Firstly, as we all know, it enhances the spatial accuracy. Enhancing spatial accuracy is one of the key benefits of integrating GNSS with GIS. GNSS provide highly precise positional data, which GIS visualize and analyze to create accurate maps and data sets. For examples, in the land surveying, accurate parcel mapping ensures property boundaries are correctly recorded and minimizing controversies. Similarly, for applications where position accuracy is critical, adapting these technologies is the best investment we can do. The second one is real-time decision making. It's kind of like an informative capability enabled by integrating GNSS and GIS. This combination allows for dynamic updates and immediate access to spatial data, empowering decision makers to act promptly and accurately. Whether in critical scenarios or day-to-day operations, real-time data integrations ensure resources are utilized efficiently, challenges are addressed proactively, and workflows are simplified. These capabilities are essential for industries that rely on spatial precision and timely responses to optimize operations and achieve their goal effectively. The third one is streamline workflows. Streamline workflows through the integration of GNSS with GIS help eliminate redundant processes, making operations more efficient and reliable. By enabling directly data mapping from GNSS devices to GIS platforms, time-consuming tasks like manual data transfer are removed. We can remove those tasks, and this not only accelerate fieldwork but also minimize errors, ensuring that the data collected is accurate and ready to immediate analysis or decision making. And broad applicability is one of the key strengths of GNSS and GIS integration, as it supports wide range of industries and projects, whether it's agriculture, urban planning, environmental monitoring, or disaster management. This integration provides the tools necessary to collect, analyze, and act on geospatial data efficiently. This integration allows organization to address diverse challenges with precision, supporting everything from data collection and analysis to decision making and planning. Now let's have a look on what are the trends in GNSS, especially for GIS applications. As we all know, technology is constantly evolving. So these advancements are not just enhancing accuracy and efficiency, they are redefining how geospatial professionals collect, manage, and use this data. In GNSS field, there are specially designed GNSS receivers specifically for GIS applications known as GIS data collectors. In the past, many industries relied on handheld GPS devices, which typically offered accuracy range 1 to 5 meter for their GIS task. This level of accuracy was considered as sufficient in the past, but the with the technological advancement, the demand for more precise data has increased. So these modern data collectors go beyond the capabilities of handheld GPS devices. They support multi-frequency and multi-constellation GNSS systems, allowing much higher accuracy, especially in the environmental like urban areas and forested areas. These advanced GIS data collectors are capable of tracking signals from all major GNSS constellations, and this multi-constellation support significantly enhance the accuracy and reliability of positioning data. In Sri Lanka, for example, these devices can usually access signals from more than 25 satellites, ensuring precise positioning. And the next thing is GNSS RTK for high precision GIS data. RTK provide real-time correction to eliminate GNSS errors. So these GIS data collectors are capable of getting this real-time correction and give position to centimeter level accuracy. So integrating with, we can integrate these data collectors to a base receiver or coarse network. Then we can measure our objects. We can get the locations into centimeter accuracy. And the third one is mobile and cloud-based GIS integration. Today there are many GNSS enable mobile applications like ArcGIS Field Maps, QField, Survey 123. These apps allow users to collect geospatial data in the field and sync it with cloud-based GIS platforms in real time. For example, let's say some company are using this kind of field software, and they are collecting precise locations of some utility or power line. They collect data and upload. They can upload it to a centralized GIS system, enabling team to make, update, or generate up-to-date data without waiting manual updates. And we can upload this data to cloud-based GIS platforms such as ArcGIS Online, Google Earth Engine, which enable collaborative mapping and data analysis. These kind of integrations ensures data collection, sharing, and analysis happens without any delay. They reduce delays and enable us to take our decisions quickly. So this mobile and cloud-based integration represent advanced GIS workflows, combining the accuracy of GNSS with connectivity of modern technology. Next thing is real-time monitoring. Some data collectors, GNSS receivers, have an inbuilt 4G modem, which not only allows receiving RTK corrections, but also enable owners to monitor the precise location of data collectors in real time. This feature ensures that teams are in the field, they are collecting data as planned, or they are adhering to the project requirements. And also it allows to address any technical issues remotely. Technical teams can log into the device web interface and identify the issue and resolve it quickly. Additionally, these kind of GIS data collectors have the ability to geotag images, further enhancing the data value. This feature allows for the precision location of photographs to be captured and associate with specific coordinate. There are specific geographic coordinates. These geotag images can be used in various applications such as in asset management, inspection, and environmental monitoring, and where especially where visual evidence is critical. So by integrating geotag images with spatial data, GIS data collectors provide rich, more comprehensive data set that improves the accuracy and the context of information. So it supports better decision making and analysis. And finally, data integration with advanced applications like GeoAI, AI, and digital twins. These devices provide high accurate positional and temporal data which can be used for GeoAI and AI applications. This kind of data can help detect spatial patterns and trends, enabling predictive modeling. In the case of digital twins, the data from the instrument we are getting, we can align with the real world by providing precise georeferencing. So this supports the creation of accurate digital replicas of physical objects, and also it's a decision making, monitoring, and optimization in the field. So far, I have discussed the features of the GNSS devices themselves, as well as it is important to know that the software we are going to use for data collection is also play a critical role in, especially in GIS workflows. There are many advanced data collecting softwares. They not only complement the GNSS hardware but also enhance their capabilities. So these kind of software solutions are designed to simplify field data collection, improve real-time data synchronization, and smooth integration with GIS platforms. Here I am going to discuss about an advanced software that we are using for our projects, which is known as T-Survey. Let's see some of key features of this data collection software, which is especially designed for GNSS-based GIS applications. The first key feature is data collection flexibility. We know the point, line, and polygon are the fundamental elements of GIS. Points represent specific locations, and line connect those points to make path or boundaries, and polygon defines areas. So this data collection software is capable of collecting various types of spatial data, including point, line, polygon. By supporting all these data types, it improves the flexibility and making them ideal for wide range of GIS applications. The second one is attribute customization. So this T-Survey data collection software has option to customize data attributes and visualization styles. So it is easy to represent data based on a specific project requirement, ensuring that the collected information is not only accurate, but they are organized, and they are easy to interpret. So we can adjust the colors, symbols, and we can adjust the size of symbols, and we can add different layers to the data points. So this customization enhances the clarity of the data and help users to better visualize and analyze their GIS data, especially in the field. The third one is data storage. So this software offers flexible data storage options supporting wide range of data types such as integer values, doubles, text, drop-down menus, checkboxes, date and times. Likewise, even in file formats. This feature ensures that the device can handle diverse data requirements across different projects and industries. Whether we are collecting numerical data or textual information or specific date time related to that data, we can store data and organize all the data. So it is very compatible with our workflow. The next thing is enhance data organization. It means user can organize data efficiently through category-based attributes. This feature helps to simplify the management and we can retrieve the information within our workflow by grouping related data together according to a point, line, or polygon. So here we can see we have 4 categories here: flora distribution, hunting incidents, electric fence, road maps. We can categorize these things and we can collect their attributes. The next one is customized data collection function. This provides the ability to create customized data collection functions according to specific GIS needs. Users also have the ability to generate multiple attributes within a single category, allowing for more detailed and organized data collection. And so this is a function we have created for some kind of forestry applications. Here you can see under flora distribution we have name, height, diameter at breast height, age, leaf tone. Likewise, we can create multiple attribute within one single category. And of course, we can get a clear view of locational and location information along with their respective attributes. And one of the key features of their ability to export data in industry standard format, such as shape files, Excels, and AutoCADs. This ensures that the collected data can easily transferred and access in popular GIS software like ArcGIS and QGIS. By supporting this wide use format, this data collection software make it easier to use to analyze, visualize, and integrate their data across various GIS platforms. And the last one is efficient sharing of functions. We can actually this software we can share customize functions by using a QR code. By simply scanning QR code, user can quickly access the tool they need on their device, which same time in the field. So it facilitates smooth collaborations among team members and ensuring data collection is fast. Now I would like to highlight one of the main project we have undertook in this year, which utilize these kind of advanced GIS data collectors. The project involved GPS, GIS field data collection for medium voltage network in Eastern Province. This project, a significant initiative by Ceylon Electricity Board, Trincomalee, helped us ensure precise field data collection, enabling better monitoring and management of the power distribution network in the area. If we look at why they need GIS data collection, GPS GIS data collection for Ceylon Electricity Board was critical in addressing several key needs outlined in their project scope. First, in terms of asset management, the project aimed to create comprehensive and accurate database of CEB infrastructures like power pole, substation, and DDLO. Then they wanted to maintain an accurate database for their infrastructure. So this database ensures by having that kind of database, it can ensure their assets are well managed, so they can address issues before they are coming critical. And for decision making support, the high quality geospatial data collected through GPS and GNSS technology provide actionable insights that enhance the planning and decision making process of CEB. And regarding the efficiency and reliability, GIS data collection reduces manual errors and save time, and simplifying the data capturing process and improving the overall accuracy of the network records. This in turn lead to more reliable outage management, enabling quick response time during power disruptions. Finally, for regulations, the project, they need to ensure the project that all data collection and management process adhere to the legal and technical framework of required for the operation and maintenance of CEB. So this comprehensive approach not only improve operational efficiency but also strengthen their capability to manage electrical infrastructures effectively. So this is the project team, and we have set a time frame of 1 year. However, within 6 months, we have successfully completed almost 80% of the project. This progress is direct result of the right technologies and the instrument we employed here. I will describe the methodology briefly. Firstly, we need to create attribute tables. The first step is to create attribute tables. They have various infrastructure components such as power pole, substation, and distribution line disconnect orders, DDLO. So these components include attributes like pole type, condition, installation date, and maintenance history, and current infrastructure We had to make all these attributes, and one power pole has 54 attributes to collect approximately. Power pole count in Eastern Province were 50,000, so it's large data set. And the data collection was done by getting precise GPS location and filling their corresponding attributes. After completing the data collection, field officers exported the collected data from field devices to central server. They export it in shapefile, KMZ, and Excel format in both WGS 84 and SLD 99. The GIS data management side, so we need to do several steps to ensure the accuracy and efficiency of collected data. Initially, errors in attributes were corrected and data attributes were standardized to meet project requirements. We merged, split, and modified shape files and geodatabases to ensure data was well organized. And special analysis tools were used to examine the relationship between infrastructure components like feeder lines and power poles. So ensuring proper mapping and connectivity, and missing and redundant features were identified and addressed, and geodatabases were created and maintained for easy access for future updates. These are the equipment and technologies that we use. We use TokNow P8 Pro GIS data collector along with PCR 100U controller, which has T-Survey GIS data collecting software installed, and we use COAST network to get RTK corrections. After completion of data collection, field officers directly exported collected data to a central server, and we use ArcGIS software for further analysis. And these are some results of our project. We have completed all these feeders, nearly 20 feeders in Eastern Province. These are some highlights on on-site training we participated at Trincomalee, organized by CEB. This training was extremely valuable as it gave us a deep understanding of specific attributes that CEB wanted to collect for their GIS project. These are some of images from field data collection. So these are the things I wanted to highlight here about advanced GIS data collecting instruments and softwares. You can further join for our field demonstration session. There we can discuss what are the new things, what are the problems we want to address here, and what are the advantages we can get by implementing these kind of technologies into your GIS workflows. Thank you.
A heartfelt thank you to Ms. Nishamani Tharunika from Global GIS Private Limited for your informative and engaging industry awareness session. A kind reminder to all who have not yet got registered, please confirm your participation at the registration desk to obtain the certificate of participation. We will now break for lunch and we will resume by 2:20 for the next session of the program, which is an industry demonstration and a practical session. We invite you all to join us for the upcoming events. Please enjoy your lunch in a natural setting of your choice, wherever you find most comfortable. Thank you.